All right, negative exponents. Negative exponents can be a little confusing at first, but let me show you the why or how we get negative exponents before I show you um, what to do or how to work out these problems. First of all, when there are more factors in the denominator than there are in the numerator, we end up with um, a fraction like this, because the x's divide out, all those become 1, and we end up with 1 on the top because 1 times 1 is 1. Down here, 1 times 1 is 1 times x is x. We end up with a factor on the bottom. It looks simple right here when we're dealing with the actual factors expanded out. But now if I take the same problem and use powers to represent this, then it looks like this. We have x to the second power over x to the third power. And if you recall, to simplify this, this is a quotient of powers, we would keep our base and subtract the exponents. But this time, look what happens. We have a 2 minus 3, which equals, let's go down here, which equals x to the negative 1. And so look, we have this negative exponent, but remember, this is equivalent to this up here, because that's all it is. This is what it looks like when we have it written in powers. This is what it looks like when we expand all the factors out. So x to the negative 1 is equal to 1 over x. So that is the rule of negative exponents. This is what they say if we put it into algebra or the rules of negative exponents. Any number raised to a negative exponent is equal to 1 over that same number raised to the positive of that exponent. Okay, so this is the rule right here. Here's the rule. Okay, so say we have this example. We have 6 to the negative 3. So let's go ahead and apply that rule. We have a number raised to a negative exponent. So what does that mean? That means this equals 1 over 6 to the positive 3. And we can evaluate that as 1 over 6 times 6 times 6 and do our multiplication. And our multiplication gets us 1 over 216. Okay, so say we have another example. Say we have b to the negative 4 power. It's real simple with variables. All we have to do is use the rule. The rule says any number raised to the negative exponent is 1 over that number raised to the positive of that exponent. And then we can't evaluate that since it's a variable. So that is the end right there. Okay, so now here's another situation that occurs. What if we have the same number of factors on the top and on the bottom? So when we see the factors expanded out, we can see for every x, there's another x on the bottom. So those become 1s right there. So we end up with 1 over 1, or just 1. So how does that apply when we're using our exponents or powers? What would that have looked like? That would have looked like as x to the third over x to the third, which was a quotient again, meaning we keep our base and we subtract our exponents. So we have 3 minus 3. So we end up with x to the 0 power. Well, what did we just say? Whenever we have the same amount of factors on the top and the bottom, it equals 1. So x to the 0 power is equal to 1. And that's what gives us our rule. Here's our rule. The rule is any number to the 0 power is equal to 1. All right, so let's go ahead and apply that rule. Say we have the number 7 raised to the 0 power. By the rule, any number raised to the 0 power is equal to 1, and that's it. That's all. That's all you have to do. Let's try it again. What if it's a negative number? Say we have a negative 4 to the 0 power. That's equal to 1. And another one right here. If we have a variable w raised to the 0 power, that is also equal to 1. That is the rule. Any number raised to the 0 power is equal to 1. All right, so let's go ahead and say we have a problem that looks like this: 1 over 7 to the 2nd power, and they want us to write it with a negative exponent. So we want to write it as a power with a negative exponent. So the rule tells us if we have something on the bottom, this is equal to 7 to the negative 2nd power, negative 2 power. So this is like going backwards on the rule. They said if we had a fraction like this, what exponent would we have had? The negative. Now this one is a little different because there's no exponent to see. So first of all, we got to figure out what the base and the exponent should be for 8. And I know that 2 times 2 times 2 is equal to 8. So because I know that, I can already start this problem. Other than that, I would have to think about it. But here I have 1 over 2 to the 3rd. So now it is in the form like this previous example that it's already in a power situation. So now I want to write this power with a negative exponent, and that negative exponent would be 2 to the negative 3. Okay. Another situation where we may encounter negative exponents is the product of powers right here, or the product of powers. So here we have the same base of 9 and these exponents. If you recall, we keep the base of 9 and then we add the 2 exponents. So adding negative 6 plus 4 gives us a negative 2. So we get 9 to the negative 2 power. And then now we can apply the rule of negative exponents, which equals 1 over 9 squared, which is 1 over 81. Okay, in the last example, say we have a quotient with exponents in it, and they're negative. Well, we still recall quotient dividing. We still have the w, we keep the base, and we subtract the exponent. So the negative 1 minus a negative 4. So what do we end up with over here? I'm going to move it down some. We have to do our subtraction here, and if you don't remember how to subtract this, subtracting a negative number is the same thing as adding the opposite. So in this case, we're adding a positive 4. And again, one technique to help you remember if your answer is going to be positive or negative is using what we call the scoreboard. So that means since the 4 now is positive, it's over here in the positive side. The 1 is negative, so it's over here in the negative side. And when they're on different sides, we subtract them just like normal. So 4 minus 1 is 3, and the positives had the biggest number, so this ends up being w. Let me write it in a different number with color. W to the 3rd power with the positive exponent, since it ended up positive. Okay.